Hi, this is a Great Car Basic tutorial for the DS1307 real-time clock. So let's have a look what a DS1307 is. It's a clock, it has time, it has dates, months, and days of the week, but it also has some general purpose memory, some RAM, that's all accessible via the I2C interface. Also has a square wave output signal. It has other characteristics which you can read at the bottom of the screen, but they're the important ones. It's a clock, it's got some general purpose RAM, and it's I2C interface. What we've got is a series of commands. I've actually grouped these together and sort of to explain them. We've got DS set of commands that control and enable the clock. If it's not enabled, it will not work. The flag is true or false. We can reset the clock back to default values. We can then set the clock, and we can set the square wave. We can read the clock, and we can read what mode it's set in, 12 hour or 24 hour, and we can read and write addresses and values from that to general purpose RAM. The code for the Great Car Basic supports hardware I2C and software I2C. Very simple to use. Typical circuit is shown here on the left of these two chips. Essentially, I have a 5-volt system, and it's pulled up to through 4.7k resistors, and the square wave I've got it pulled up to 10k as well. I've got a battery attached to keep the clock consistent, which is on V back to ground, and I've obviously got the watch crystal. Very simple setup. So what have I got here so I can show you? I've got a microprocessor, I've got a LCD attached to that, and a DS1307 attached to that. I'm not showing the interface cabling, but what's important is I've got these buttons, key 1, they're called the set button, and the mode button on key 2. And essentially they're just pulled low, and when I push the button, they're going to go high. So I'm going to have some logic around that, and I'll show you what that clock is. Now for this demonstration, I've actually got the LCD routing through to a serial terminal. It emulates it, so it looks identical, and that looks like this display here, and that is the time, and that's coming from the device. So this display here is the same as you would get on an LCD. Okay, so if I push down the mode button, hold it down, it will put it in PM mode, and if I release it, it will go back into 24-hour mode. And so that's the functionality of the two buttons. I can also press the other button, which is set mode, and it will take me into the settings, and I can then set my days and months, etc. And that's how I set it. Well, I'll just reset the whole chip. I've actually got it hooked up to a pickaxe only for power. I've done that for a particular reason, so I can show you. And when I reset it, you can see that the doesn't lose its time because I've got a VBAT. I've got a battery attached to it. So let's have a look at the code itself. Okay, we'll look at a couple of other things. So if I just master clear that, I can see that I've got a DS1307 chip in there because the code tells me this, and I've got it set to hardware. Great Car Basic, and depending if you're running it on hardware and software, it will just flash that up, and then it will just show you. And there we go. It's running. It's running at 400 megahertz, and that's coming from the code. So what I've got is my program here. It's my test program, and this is essentially it. I need to put in my DS1307 command, and then I need to tell it it's on the hardware for the I2C settings for the SSP module for this particular chip, and you can see that it's got a rate of 400. These are the two data lines I need, and I need to set these to in, and it's a master mode, and that is it. The rest of it is pretty simple. So that's the setup. We can look at this is like a command reference I've put in here for you. I'm so sorry. It's here. I put a command reference in for software, but we'll come back to that in a moment. In here, I've got all the commands. Quick reference. You can enable, reset, set clock, same list as what we saw before. Read and set things like the memory. And what this essentially does is just a demonstration program, so that you can actually set this thing up. Okay, you can do what you like with it. It's got a small loop in it, and this is the main program. This is the main. It says update display. Only updates every second. And if you're pressing the set button, changes the setting. Press the mode button, changes the mode. So what else can I show you? I can show you things like the speed of the chip. I can show you how to do software. But let's look at. We'll change this to software. So what I'm going to do to change it to software is I'm just going to comment out all the hardware stuff. I will undo that. I'll uncomment out all the software stuff, and I'll comment up the hardware. And so I'm going to change this to software. This is master mode. I need two connections again. I need to disable the interrupts. And if you're running on different chips, you might have to change the timing, but they're pretty small standard. Okay, I'll compile that up. I'll look inside my and it's loading it's going to auto load a piece of code here called that type of chip with a serial connection. I just know that it's got a serial connection on it because that's my LCD emulator. It's going to load that in, and in here we'll see that pop up. And there we go. I've just turned it over to the software. And so it does a quick check, and now I'm running it in software mode. And it is as simple as that to change it between hardware and software in terms of the demonstration code. Set the time, you just hold the button down, set your values, but you can set it from the code down here. So if I show you in here, this is set clock. That's a set clock. Let me pull that out. And we're going to set the clock to a random time, and then we'll let the program run. So I'll pop that back to, I'll leave that on software mode. I have no problems with that. We'll see it quickly compile. Great Cow Base. It takes about 14 seconds to do this because I'm actually got the processor running quite heavily. I've got graphics, I've got the compiler running, and I'm capturing the video here. And it's going to set that to a time. Once it's set it, we'll have a look at that time and see if it relates to what I set down here. So I said set it to 19. It says on the screen, as you can see. Let me just pull that across there. Do it like that. There we go. The first parameter you set it to is the hours. The hours. And then the minutes. That's the 38 in here. Then the seconds. Well, that was set to 0. First day of the week, which is a Sunday, 18th of January 2014. And so this command is what's on the screen. That sets the clock to that particular time, which is exactly what we wanted. The rest of things like reading the date populates these variables: date of the week, date, month, and year. Read the mode, comes back as AM or PM. You need to enable the oscillator or enable the flag. It's the same command, but you do need to do that. It's an option. You can use enable flag or enable oscillator. You must set it, otherwise the clock doesn't get running. And then I've got set the square wave, and then we're into the program, basically the main basis of the program. So that's running. I've stopped it over here. I'll there we go. It's running. I'll quickly put that back to it where the date time it should be, and set the month. Well, that's set to the 1st. That's good. We'll set the date to the 25th. The year, actual fact, is a year out, isn't it? Yeah. So I just need to increment that by 1. Now, it is a Sunday. So I'll leave that as it is. We need to change the hours to 14. Now, my little switch here bounces sometimes, and it just bounced then. That was a good demonstration of the bounce. And it will take me a few minutes to set this up properly, because it's bouncing on that switch, and once it bounces on the set switch, it actually moves it on to the next parameter. So, a bit of a... Oh, I just went through it. How annoying. What I'm going to do is program it manually. It's quicker. Okay, we'll set the clock up properly. Right, we know it's 14:29, no seconds. Today's date is the 25th. That's right. It's quicker. Maybe I should set that for 28 seconds. It's going to be a minute fast. Quickly recompile that. But it just shows you that these commands work. And whilst that's running, I've actually got an analyzer here. We can actually see an analysis of the code. So this is actually, looks all white, but in actual fact they're actually data streams. This is a SAIL logic, and if I look back at my clock, it just went bing. There we go, it's just started off. It's a bit fast, by about 5-6 seconds. That will do for today. I can actually look in on here. This is my protocol analyzer. If I pick a point here, I can actually pick the starting of a data transmission. I can zoom in on rotating my mouse, and I'm actually looking at the actual protocol here. It says this is doing a write. This is setting up the device and getting some data. So this is just proving to you that it's I2C, it's live, and the time it's running, its timing, that's running at about 200 kilohertz on the software. It runs 100 on slow mode in hardware, and 400 at in hardware mode, obviously. So you've got 3 different speeds, and you can change the interblock on this clock timing so that you can pick a particular time for your device. But it seems to work on all 3 speeds. Over here we've got operational, and that's really it. So we've got a set of commands in here which enable us to control the clock. We've got square wave control, which I could show you. If I bring up my scope, let me just plug a scope in. I'll plug a scope in here. It's unplugged at the moment. I'm going to plug a software scope in. It's just loaded that. I'm actually looking for my software. I'll just connect to that. Oh, there we have a square wave on that oscilloscope signal. What are we looking at here? Each square wave is a 1 second division. We have a square wave of 1 second. Okay, and that's just the square wave coming out of the clock. And so what we're looking at there is the square wave coming out of the out pin here into my oscilloscope. It's clearly programmed for the default parameter is 1, and it will put it to 1 hertz, which is what it's running at. That's fantastic. I'll just shut that down because it uses quite a lot of power. So what I wanted to show you was a DS1307, which is a real-time clock. So the commands, which are documented in the README files, and here, finally the circuit, and that it works, and that you've actually got very simple real-time clock. You can use this code then to integrate into your own programs. So with that, I'll call that a wrap.